Okay, in this video, we'll discuss our question 3 for a question paper, a physical sciences paper 1 from grade 11. This was a question paper by Baling on November 2018. So lana focus only on question 3. So question 3 ufundeka ngalendlela le uthi a box with a mass of 45 kilogram is pulled with a force of 90 newtons at an angle of 50 degrees to the horizontal. The box moves at a constant velocity. So the constant velocity kulesa statement is a keyword, ne? It's a keyword, right? Ngoba lana sizo apply only Newton's first law. Ngoba that in Newton's first law apply only if an object is stationary or an object is moving at a constant velocity. Njengala basitshela ukuthi le object naba apply a 19 Newton force at an angle of 50 degrees izomove at a constant velocity. Manje same ukuphendula question 3.1. So 3.1, but it define the term kinetic frictional force. So the very same object abasinike yona sithathe as an example just to explain the term. So there's a 90 Newton force applied to the object, no? At an angle of 50 degrees, and the object is in contact with a surface. So uma the object if the object is in contact with the surface, so the minute it move iso experience a frictional force. So now apply this 90 Newton iso move to the right the object, and then I move to the right iso experience a opposing force. An opposing force esibizwa ukuthi a kinetic frictional force. So a kinetic frictional force is always associated with an object in motion. The minute the object move, I experience something is the kinetic frictional force. Ne? And then there's another type of frictional force esibizwa ukuthi static frictional force. Leyo frictional force leyo is associated with an object in that is stationary kanje. So now to define the term ngathi is a force that opposes a moving object, let's say maybe relative to the surface that's in contact with the object. Now why define so now 3.2 state Newton's first law of motion. Well, this one is the easiest one. And an object will remain in its state of rest or motion unless a non-zero force acts on it, right? So now giveaway marks now, né? These are giveaway marks, and then I don't think it was necessary for me to define. But anyway, 3.3 calculate the magnitude of the horizontal component of the applied force. Let's redraw the object. Let's just redraw the object. There's a 90 Newton force applied, ne? At a angle of 50 degrees. So le angle nangabe apply a force at an angle izoba nama components. Like in this case izoba a horizontal component as well as a vertical component. The vertical component calculate as Fy equal to 90 times sine 50 degrees. The horizontal component as it to Fx is about 90 times cos 50 degrees, right? Lana, but this calculator only the horizontal component of the applied force. So the horizontal component is about Fx equal to 90 cos 50 degrees. Lama formulas for like values for calculating the vertical and as well as the horizontal components usebenzisa trigonometric ratios to calculate lama components wakho. It's just our manipulator lawa formula wakhona. So the answer here is about 57.85 newtons. Remember, this is a force, so make sure to specify a direction to the right. Now 3.4 uthi calculate the magnitude of the normal force. So bheka now the magnitude of the normal force. Let's draw a free body diagram just to understand ukuthi kuqhubekani la. Just with this understand ukuthi kuqhubekani. So Fg, right? And then normal force, and then bani Fk, and then applied force of 90 newtons. But then lama components la ungawakhohlwa la, ne? Wona akadingeki ku free body diagram, but then that's why I'm using dotted lines to show them. So bheka ke la, vertically now 1 2 3 yama forces are at play la. So in order to calculate the normal force kwamele include uthola the vector sum yaka normal no Fg no Fy. So ngithini ngaloko ke? Ngichaza ukuthi F net vertically it's gonna be 0. F net is gonna be 0, but isifuna in normal force, and then the normal force is ophuma so ke. If we start the upward direction as positive, ne? If we take the upward direction as a positive, so uzoba positive normal force, a positive Fy, and a negative Fg. Nangis eta, so kwamele zinginikeze a 0. Now let's manipulate this equation and make n the subject of the formula. So it's positive Fg, negative Fy. So our normal force is equal to Fg subtract Fy. So in normal force yakho, whenever there's a force applied at an angle izophuma so kwamele calculate the net force vertically, and then when I end the subject of the formula is gonna be equal to Fg, it's 45 times 9.8 minus Fy, it's 90 sine 50 degrees is equal to, so the normal force is gonna be 45 times 9.8 minus 90 times sine 50 degrees. So answer it's 372.06 newtons up, right? Up. Ngoba answer iphuma as a positive, so the upward direction is considered positive. So manje asenze 3.5, but first I think erase la. Okay, now 3.5. With 3.5 siyabona ukuthi bathi calculate the coefficient of kinetic friction. So kinetic friction is calculated as Fk is equal to mu times normal force, normal force is that we calculate for the object, but then kinetic friction anginayo, and then this mu i-value esifunayo iloku coefficient of kinetic friction, it's the unknown value. Now fk anginayo, normal force nginayo, so the first thing komele siyenze la komele calculate u-fk, but then siyazi ukuthi the object move at a constant velocity. So if an object move at a constant velocity, F net horizontally, F net will a 45 kg object horizontally, it's gonna be equal to 0 because of the object move at a uniform velocity or a constant velocity. So, but ngoba i-force yamba apply at the 90 degree, so at the 90 Newton force, but at an angle of 50 degrees. So horizontally ngizoconsider only fk nobani no fx, which is the horizontal component yale 90 Newton force. So f net is gonna be equal to 0, and then f net horizontally is equal to what now? I started to the right as positive, so it's gonna be fx minus fk, which is equal to 0. Now fx is some calculate previously, but the calculate question what now? Calculate the magnitude. Yes, the horizontal component of the applied force 3.3. Damn it, angizayikhumbule nale value nakhona. But anyway, asenze so as it recalculated, but anyway, so it's gonna be 90 times cos 50 degrees minus fk. So into kamele siyenze sifuna calculate fk kuqala. So fk is equal to 90 times cos 50 degrees. So ngamanye amagama fk is equivalent to fx. So lama forces lawa ayalingana, then akalingana azocancela each other out. That's why the object move at a constant velocity ngoba f net wethu is equal to 0. So fk wami is equal to 57.85 Newton, right? Newton to the left. Also about to the left, I need. So therefore, what is calculated mu, right? Mu is equal to fk divided by Newton. I'm going to divide both sides ngo n la. Ngizosala no mu. So mu is equal to fk. The fk is that we calculate, it's 57.85 all divided by but anyway ithini konje 45 times 9.8 minus 90 times sine 50 is equal to, so in normal force it's 372.6 equal to, so noma ungayiphosa le video ubuyele back ubone ucheck le value le yiyo this one lana I had to recalculate ngoba ngikhohliwe le value le. So mu is gonna be equal to 57.82 divided by 372.06 is equal to 0.16. So this is the final value yaga mu. So mu wami is equal to 0.16. Akana my units. Why? We coefficient. Ungayenzi leyo mistake le, ne? Where so the Newton or whatever. Mu akana SI unit. We ratio, we constant, so without any SI unit. So 3.6. Well, with 3.6, but will the coefficient of kinetic friction change if the angle of the applied force is decreased? Write only yes or no and give a reason. So the answer it's a no la. I-reason ukuthi it's because coefficient of kinetic friction coefficient of kinetic friction I depend on the applied force, but then it depends only on the nature of the surface that is in contact with the object. That's the only reason ongayinikeza la. So thanks for watching. Uma ngabe uyi-enjoyile le video, just leave a thumbs up. Nangabe uthole le video ukuthi useful, share nabangani bakho. And then nangabe new to my channel, just consider subscribing. And then thanks for watching. Uzobona kule video ilandelayo. Peace.